Hi, I'm James the Light Guy, and today we're going to take a look at a couple of different variants of the LED DRL with sequential turn signal and do a tutorial and troubleshooting. I have two variants here. On the left we have a front variant with a white DRL and sequential amber turn signal, and on the right we have a red DRL with amber sequential turn signal. These are for use in tail lamps or rear facing signal assemblies. First, let's take a look at the three wires. On this set, I stripped them back a ways. So we have three wires. We have a red power wire. This positive wire is for the main DRL, whether it be the white variant or red. The common ground for the assembly, and the yellow wire is for our sequential turn signal. Both the white variants and the red variants use the same color coding, for the red wire being the positive for the DRL, amber or yellow wire for the sequential turn signal, and black wire for the ground. Using our power supply, we are going to use the black wire for our common ground. This red wire will be our DRL signal, and this positive wire that I have put an amber, or rather orange, piece of tape on will be our turn signal indicator. First, let's grab our strip and hook up the red wire to our day running light circuit. And actually, let's fold that back to keep it from grounding out and shorting. There we go. Next, we'll hook up our ground wire. Alright, turning on the power to our power supply. At 14.4 volts, we're drawing just shy of 1 amp. These strips have double-sided sticky adhesive on both sides of the flexible shroud and diffuser. These are made up of strips of LEDs, which gives you a vertical flex but not much of a horizontal one. When we trigger the turn signal with our other power wire and the yellow connector here, you can see it disables the white light and activates the turn signal, and then that runs for a couple of pulses. Before the white light returns. That's all being controlled by this small brain box. As you can see, it identifies which ones are for the main power, ground, and turn signal power. I can get that to change brightness down. These don't get very warm since they are so separate, and each individual chip is not very powerful, but they do give a nice even glow. Taking a quick look at one of the red sets, we'll disconnect that. The white balance on my camera may be a bit off, but I can assure you that this is actually a very vibrant red in my hands. Grabbing our turn signal wire, and then it returns back to red. Now, some of these variants require you to have power to the main light before, and having just the ground connecting the turn signal wire to power won't do anything. In this case, it does still function. However, with those other variants, let's grab our white cable again. What you can do to bypass that is keep your ground isolated and take your main power to the DRL and your turn signal and simply twist them together. Now, when we connect our ground wire and our turn signal wire, you can see that it doesn't illuminate white, it only does the turn signal. Going back to our red variant, we can do the same thing once I remember which wire is which. These ones. If we ground the black wire and connect both of these wires to our turn signal wire, fidgeting around. There we go. We can see that only the turn signal functions. If we separate out our turn signal wire, it becomes red. But combining both of them, the turn signal function overrules the day running light. We didn't get a good read on the tail light one. Let's see what the red draws. If I can get a good connection, there we go. We can see in tail light running, we draw half an amp at 14.4, and when we trigger our turn signal, that drops down to anywhere from 0.01 up to 0.4 amps. In any case, that's all I have for today's video. If you enjoyed it or found the information useful, please like and subscribe to the channel, perhaps share with your friends, and check out one of my other videos while you're here. Until next time, I'm James the Light Guy.